In question number 9a, we're going to look at solving for secant theta equals 2. To solve this, what we want to do first is convert that secant theta into a cosine. So I'm going to use a reciprocal. And on the other side, I also need a reciprocal. So we're going to have cosine theta equals 1/2. So if cosine theta equals 1/2, we can draw a picture of this. In fact, we can use the same pictures we used in the previous example. So we have, in this case here, we can see that the cosine is horizontal. It's a special angle. The 1 is along the horizontal, and we have 2 along the radius. And we can see that in quadrant 1. This can also be found in quadrant 4. And it's going to be drawn like this. And so that angle here then represents our theta 2 angle. So our theta 1, we're going to get as 60 degrees or pi over 3. And then theta 2 is going to be the angle that's going to be found in quadrant 4, because we can see that it's going to give us the same horizontal length of positive 1. And so this position is going to be 5 pi over 3. Or we can also, because we're going to do this for all real numbers, I think this is all for real numbers. Oh no, sorry, this is between 0 and 2 pi. We can't go backwards, okay? Although it's the same as negative pi over 3, we need to go in the positive direction. So we get these two solutions. And since we're only doing one period between 0 and 2 pi, these are the only two solutions. We don't need to show the repetitions in this case. For for B, we have sine, but we want to solve for, we have sine squared, but we want to solve for sine first. That involves first undoing the square, so we get plus minus 1/2. So once we have sine is equal to plus minus 1/2, so I'm just going to write that over here, sine theta equals plus minus 1/2. We're now going to draw this in the positive vertical position and the negative vertical position. The 1 is going to be the short side of the 30-60 triangle, so it's going to be 1 and 2 like that. Now it's going to be positive, so we can find that in quadrant 1 and 2. So there's my 1/2 ratio, so there's my theta 2. This angle in here represents theta 1. And because it's negative, we can also find it in quadrant 3 with -1, -1, and 2. And so that angle here, that position is going to be, it's going to be 210 degrees, so that's going to be 7 pi over 6. Theta 2 is going to be in the 150 degree position, so that's 5 pi over 6. So I'm going to start writing these down. So the theta 1 solution is going to be my 30 degree position, which is pi over 6. My theta 2 is the other positive solution, which is pi minus pi over 6, or 5 pi over 6. The other angle in the negative quadrant, that's going to be my negative 1/2 ratio. That's going to be 7 pi over 6. And we have one more in quadrant 4. It's symmetrical here, so it's going to be -1, 2, and that's going to be my angle position for, I'm going to call theta 4, and that's going to be 11 pi over 6, or 330 degrees. Those represent all the solutions from 0 to 2 pi. In this question here, again, we are only looking for 0 to 2 pi. So we don't need to do all real numbers in this case.